The tropical ocean is the world's largest solar energy collector. The clear tropical water is deep blue because it efficiently captures and stores sunlight. All of the world's weather is powered by this natural heat engine. In comparison, all of human society's energy needs can be satisfied by less than 0.1% of the energy flowing through this natural system. Hello. I'm Dr. Hans Krag, President of OCEAS International. The enormity of this renewable resource and its potential contribution to human civilization has been the driving force for OCEAS International and its strategic partners to pursue commercialization of a new engineered system which uses as its basis the old idea of ocean thermal energy conversion, or OTEC. There have recently been several technical innovations as well as changes in the economy that now make OTEC systems a cost-effective alternative to fossil fuel-based systems for many tropical island communities. OTEC systems are particularly attractive because they can not only supply baseload electric power, but also fresh water, air conditioning, ice, aquaculture, agriculture, and hydrogen. The biggest potential for OTEC is in offshore installations to produce hydrogen on a large scale to eventually end our dependence on fossil fuel. The world's limited reservoir of hydrocarbon resources is much more valuable as a source for industrial materials needed by future generations than to be simply burned in an instant of human time. OTEC's time has come. OCEAS International and its strategic partners constitute the world-class team to evaluate, design, construct, and operate OTEC systems for tropical island communities, as well as produce the fuel for the upcoming global hydrogen economy. I invite you to continue viewing to learn more about how OCEAS International can benefit you in the development of this resource.
The natural heat engine which drives the world's oceanic and atmospheric circulation patterns derives its immense energy from the thermal differences between the tropical ocean and the Arctic oceans. This heat engine is best represented by the natural hydrologic cycle depicted here. OTEC technology closely replicates this natural cycle of evaporation, energy transfer via wind and heat dissipation, and freshwater distribution via precipitation. The tropical ocean, shown in orange, collects large amounts of solar heat energy. The energy absorbed in the tropical ocean in one day is equivalent to approximately 245 billion barrels of oil. If less than 0.1% of this energy could be converted into electrical power, it could supply more than the entire world's energy needs. Utilizing the same energy cycling in the natural global heat engine over thousands of miles, OTEC vertically taps in less than 1 kilometer the most immense renewable global energy resource.
OTEC is in fact an idea of the 19th century. It was thought up in 1881 by a French physicist. It was first tried out in the 1920s, the late 1920s, by a French engineer, Georges Claude, and it was found to work. Since that time, there have been several improvements in technology and changes in the economy, and the net result of that is that OTEC is now a potentially viable alternative and is worth pursuing.
The principal innovations over the past decade of OTEC systems have been accomplished by OCEAS strategic partners Exergy Incorporated with adaptation and operational experience of their patented Kalina cycle to OTEC designs, as well as the successful design and development of numerous commercial-scale cold water pipe systems by another of OCEAS strategic partners, Mackay Ocean Engineering. No other company has successfully deployed cold water pipes of this magnitude. A cold water pipe system can now be confidently designed and deployed for commercial-scale OTEC applications. An OTEC system can be the basis for harmonious, self-sustaining island communities. Independent of fossil fuels, operational costs are reduced, predictable, and stable. Island communities can now create a complete infrastructure providing food, water, and electricity which can support industry, tourism, and trade. The primary product produced by an OTEC system is electrical energy. The power system chosen by OCEs for their integrated OTEC system is the cleanest cycle, a modified Rankine cycle utilizing an aqueous ammonia working fluid which allows for a dramatically increased efficiency over previous designs, which with the addition of another system component, the recuperator, captures additional heat generally lost. This significantly reduces the cold water requirements, effectively lowering capital costs. One of the primary benefits associated with an OTEC system is the significant production of fresh water for domestic, industrial, or agricultural consumption. With the immense flow of seawater inherent in an OTEC operation, a natural synergy exists for the desalination of seawater which can be economically performed with no environmental consequences. This significantly reduces the capital cost in comparison to a fossil fuel-based desalination plant. By utilizing innovative techniques developed by OCEs, freshwater production can be further optimized while minimizing power system losses. Nearly all tropical island nations have a relatively uniform need for air conditioning. Traditional electrical air conditioning systems are energy intensive and represent 40% of energy use in typical buildings in tropical island communities. The OTEC power system pumps large amounts of cold seawater to the surface and therefore can also provide direct seawater air conditioning to commercial loads adjacent to the power plant. An OTEC facility which incorporates seawater air conditioning will not only provide base load power to the local community, but also reduce load requirements. Aquaculture is a particularly attractive co-product available in an OTEC design. OTEC-supported aquaculture has multiple advantages. The low temperature of the deep water allows the culture of valuable cold water organisms in the tropics over a wide temperature range. The water is nutrient-rich and free of harmful organisms. This permits the disease-free culture of sensitive organisms and the production of pure plant cultures without interference from competing species. Temperate fruit and vegetable crops have been successfully grown in tropical climates by utilizing cold seawater to chill the soil. The combination of high solar insolation and cold roots has enhanced production and quality of many valuable crops from nearly every known climate. Through artificially induced dormancy, by adjusting cold water flows periodically, up to 4 growing seasons can be achieved in 1 year.
What you have is a system that gives you multiple products, each of which can add to the economic benefit of this approach. You have one investment, a capital investment, and you get many revenue streams from this. The largest potential benefit of OTEC for human societies is in the production of hydrogen, because that is the fuel that can be transported and used in all of human society's energy needs. Application builds directly on the experience that comes from our oil explorations in the deep ocean. The oil companies have developed systems to not only tap into the resources in the deep ocean, but also transport the resulting product to the land. Eventually, the oil companies will inherit this technology because it's a natural outgrowth of the existing developments for deep ocean exploration for hydrocarbons. So the importance is to have ocean experience and to be able to deploy items in the ocean and maintain ocean devices. And this is where the OCEs International and its strategic partners, Mackay Ocean Engineering, have the greatest experience and have had the greatest success.
OCE's integrated OTEC systems can now be confidently designed and constructed based upon proven existing technology. OCEs works directly with industry and resource officials to customize an OTEC system to meet local infrastructure needs.
We hope that you have found this presentation helpful. If you require more information, please contact us. Thank you.